So, hello everyone. Hello, hello. I'm happy that some of you are here to listen to the first demo pitch today. And my name is Benjamin Felbrich. I'm one of the co-founders of Robotics. And we are very happy to present our technology at the booth today and in this presentation. So at Robotics, we want to build the next generation of smart robot components. As the name suggests, all of us co-founders have an extensive background in robotics, and we've been building robotics and programming robotics with a combined experience of around 50 years, all of the founders together. And we wondered about a question a lot. Why is it so hard to build robots? Why are robots so difficult to build? Insular systems or insular products like your Franca and your KUKA or your robotics product basically range are great and for a lot of applications. But as soon as you want to customize a system by just maybe put a gripper and a camera on a manipulator, or you want to make even more customized solutions, it becomes very hard and messy to build something. The reason for that is that there are many vendors for hardware and software components that offer mutually incompatible partial solutions. There's no standardization for robotic hardware on this component level. So if you want to build something, you have to integrate your microcontroller with your sensors, and your servo motors have to download and compile drivers, set up all the software. It takes forever. So engineers need to spend around 80% of their time in solving low-level hardware integration problems. And we think that makes it very difficult and costly to adapt or extend existing robotic workflows. So easier robot development could make engineers 5 times more productive in actually building innovative and interesting products. Easier robot development would also drastically accelerate scientific research in robotics and AI. So how do we want to solve this problem? Meet Robotics. What we do is we offer a set of components of interoperable AI-enabled robot components, and we basically put all the different functionalities that a robot needs to have, say actuation with a gripper or a servo, or all kinds of different sensors, and we take these functionalities and wrap them in dedicated components that are very easy to combine with one another to build larger systems. All of these components, like the servo component that you see, a gripper, a camera, support native ROS out of the box. So you just plug in a cable and you get ROS messages, and they support an embedded AI. What this means I will talk a little bit about later. So we love ROS. We're not the only ones to do that, obviously. A lot of the vendors and exhibitors here at the fair also think that ROS is the future of automation. And kind of what we do a little bit in a way is trying to build a hardware equivalent of what ROS is doing on the software level. So this modular approach of easily extendable systems, we do that with hardware. So how would this look like? If you buy one of our components and plug it into your computer, it just needs one cable, USB-C, because it can do communication or Ethernet via USB-C, and then starts publishing super low latency ROS messages, and it's also powered over this cable. And then you can start daisy chaining components. You can basically extend the functionality of your system at will, say a camera, your IMU, your servo, a 5G module, and so on and so on. And what this allows you to do is very fast and rapid prototyping of robotic systems and simple customization. So with this, for example, you could build pure Olive systems that only consist of our own components. But maybe even more importantly for many, you can also extend existing systems. So you can take your manipulator, your commercial manipulator, or an AGV robot or a delivery robot, and just maybe put some sensors or some components onto that system and basically extend its functionality in the way that you want. And this is exactly what we're presenting with our demo. This is the demo. This is our dog here. Let's call him Oliver. Maybe Oliver can stand up now. And this demo consists of 2 pieces. You see on the left my friend Leox, he's over there. On the left, he's wearing a headset, and this headset is equipped with an IMU module that we made. And on the right, the second part is the dog. It's basically a mobile off-the-shelf platform that happens to speak ROS2, that makes integration easy. And we extend this with custom functionality by putting a pen-tilt roll unit on it. So this pen-tilt roll unit consists of our own components. That's a stereo camera and 3 servo motors, and they communicate with the IMU. The IMU measures the orientation of the headset, and that is then sent to the pen-tilt roll unit that basically translates that into motion. So if you look over there, my friend Pasa, he is wearing the headset, and as he moves his head around, so does the pen-tilt roll unit. So this is a robotic telepresence that can be used for all sorts of interesting things. And you're absolutely welcome to check out our demo and come over and try it for yourself. It works very well. We were very lucky to actually put it on Minister President Söder's head. Yes. Okay. So why do we do this? Sorry. Why do we do this? What is the benefit? Compared to conventional methods of integrating, say, a gripper, a microcontroller, and a camera with an existing system, where you have to do all of this integration work, we can speed up setup and development time by 10 times. So our goal really is to eliminate low-level hardware integration efforts, not just minimize it, but completely eliminate it. And we also want to provide ready-to-use apps and pre-trained AI models that you can load onto the component. So you basically get your component, load an app on it, and you're ready to run. How do these apps get onto the component? With our own Olive Robotics App Store. So you can basically download apps and put it on there. You can also share your own apps. You can also share your own pre-trained neural networks. Say, for example, for a telepresence like this, it could have an application in construction robotics. So you can pre-train a neural network that is able to detect construction-related objects like hammers and screwdrivers. And then you can also share that model on our App Store and sell it, make money off of it. So we're talking a lot about this AI and smart components, but what do we actually mean when we say that? So let's take, for example, our camera module. This is the current design of our camera module, and this ships, like all of our components, it ships with a Coral AI accelerator module, a TPU. It is pre-configured with the software stack that you need for this kind of AI computation. So it comes with your CUDA, your PyTorch, TensorFlow Lite, OpenCV, and so on. And therefore, out of the box, it is ready to run edge inference with pre-trained neural nets. It's also able to run more complex AI-powered custom apps, and it's therefore part of what we call the Olive Robotics smart component ecosystem. So if we're looking at the hardware a little bit more in detail, we have our chip design here that has a real-time processor, a CPU, that runs our own operating system. We call it Olix OS. It's a Linux derivative. It also comes with this TPU that can run 4 teraops per second. And it does Ethernet over USB-C communication. So you only need one cable for very low latency communication. But if we talk about this smart component ecosystem, what do we actually mean by that? So we don't have to stop at the camera, because all of our components can make use of this TPU and really become smart components. So for example, a smart IMU sensor could use IMU data to detect shocks or shake or more complex motion patterns. So really we can make use of this TPU in all of our components. And then it can send this high-level information to the servo motor that then in turn makes use of that info and its own back EMF to maybe adapt its own actions based on a pre-trained policy. So all of these things are possible. You can do even the same with a power unit where you can detect patterns in current draw per module, or even a hub that can have a higher level decision-making smartness at the intersection of many modules. So this is what we call embodied AI, that we basically distribute the smartness of the system into its ends, into the components, and we don't have to transfer the RGB data of the camera to a central processing unit anymore that congests the network with a lot of data. We basically only forward the high-level information that we care about. And with that, I'm pretty much through with my presentation. The one thing that I want to do now is give you an impression of what it would look like to make use of this workflow and buy one of our products with this little video here. And now it should play the video. Ah, there we are. There was just a delay in there. So you would start your journey with Olive Robotics by going to our website and check out our online configurator. This is really where you can build or basically design your own robot. It's all browser-based, so you don't have to install anything. You just go there and start modeling. All the components that we have, you can see on the left, and you just drag them onto the canvas and start designing whatever you want. So this design, for example, is a little buggy with 4 wheels that's equipped with a camera, and you can move the connector pieces around and see what it does. But you can really play around with it, and it's a very intuitive UI, let's say. So let's give the user a little bit of time to see what they come up with. Okay, so this is now good enough. And what you do next is you click on the little shopping wheel on the shopping cart, and it takes you to our website where you get a list of the components that you want to buy to get the exact robot that you just assembled. So you just hit buy, and then you receive your components. This is how this kit would look like. And you take it out, and you basically have everything you need in there to start working with it. Maybe before you put all the pieces together, you connect them individually to your computer. Say a servo and an IMU, or sorry, a servo and a camera sensor. And then you can browse. Once you set up the chain, you can browse to the UI, to the web-based UI of each component, and check out low-level controls. So this, for example, is the IMU. You can check out that module at our booth over there. And that basically gives you the sensor information and low-level controls. But if you want to extend these low-level controls, for example, for the servo, you can control the motor back and forth. And if you want to have higher-level functionality, you browse to the App Store and extend it with the functions that you want to have. The daisy chain offers all this functionality. The AI camera prototype you can also check out at our booth. It does object detection and yeah. So now that you made sure that all of the components work, you can put them together with this easy assembly model with a few screws, our own connectors, and assemble the thing to the robot that you actually want to have. Plug in the USB-C cable and you have a robot. That you made sure that the robot works, you browse to the App Store and start downloading and installing the apps that you want to have. Maybe there's a face detection app, object recognition, whatever you want. You just upload that over the same web UI to the components. And there you have it. It's on the component now and it can follow you around. Okay. Great. So with this, I think we can skip to the last slide. I can skip to the last slide, sorry. And this is our team. We're happy to meet you at our booth and happy to answer all your questions and get in contact. Thanks a lot.